Hey there, you 12s. In this example here, we're looking at maximum flows. What we learn in this section here is that the maximum flow is equivalent to the minimum capacity that's available, which sounds very ironic, doesn't it? But essentially, it's trying to say that if you have a pipe, right, just to give in terms of water, if water goes through this section, so it's flowing through at, say, I don't know, let's just make it up, 30 liters per minute, right? 30 liters per minute comes in, and even if I connect it to a larger pipe, right, the amount of water that still goes through is still 30 liters per minute because that's what you're putting in, true? So that means even though it's a bigger hole or output, the water pipe still only pumps out 30 liters per minute. So what they're trying to say is the maximum flow is equivalent to the individual pipes, but the minimum amount. So in our case, it's 30 liters per minute. So even say if this larger pipe has a capacity or a maximum possibility of running, say, 50 liters per minute, right? It still doesn't matter because the amount of water that goes through is only 30. So even though this has a lot of potential, it will only be spitting out 30 liters per minute. So similarly, if I connected, say, a smaller pipe to it, all right, it's still going to be only flowing out 30 liters per minute. So when we look at that kind of concept, then we look at this diagram over here, and it says that you've got points A, B, C, D, and E. Each of them are representing, there's a weight, and that weight represents the maximum number of cars. So there's 300 cars going from A to B, and there's 500 cars going from A to D. So if we think of them as pipes, this one obviously has a maximum of 300. You can't put any more. So 300 is coming this way. And that means even though this road here can contain up to 600 cars, remember there's only 300 coming in. So that means 300 will still be going this way. And then same thing at C to E, though you can take a capacity of 800 cars, there's only 300 coming through. So from A to E already, I can see that we're going 300 all the way. But alternatively, you can look down here. This is A to D, which has 500, but then from D to E can only take 150. So even though I have a lot of cars coming through here, it's being funneled at only 150. So that would mean that there will be a massive traffic jam over here. So 150 will only get through. So even though I started off with 500, the result is that I'm only going to be coming out at 150 by the time I get to E. So together, actually, I'm probably answering the question as I'm going. What is this? A says find the maximum traffic flow from A to E through town C. So that looks like they're asking us A to B, B to C, so through town C to get to E. And like I said before, that was a maximum of 300 cars that can get through. So part A, our answer already in part A is you can see that A to B to C to E, okay, has a maximum flow of 300 cars. Okay, so that's the first part. And then in part B, you can see now they're asking, well, what is it if I went from overall? So this is where you got to take into consideration. We already knew there were 300 from A to E, but from the top. Okay, so from A to B, B to C, and all the way to E. So that's 300 overall will come out. But then over here, we can see that though there's 500, remember it gets funneled at 150 from D to E. So that means from here to here, I still only get 150. And so therefore, at the end of the day, the total results, the total weight, because they say overall, so A to E overall has to be equivalent to max flow of 300 plus a max flow of 150 from the other route. And that gives you a total of 450 cars as your max flow. Okay, and then in part C, this makes it a slightly more different problem. They'll say a new road is being built to allow traffic road from D to C. So in our diagram, we can see that, well, if I needed to have another road, so let's connect D to C now. Say it's a maximum flow that can carry 500 cars per hour. So this now has 500. And again, add this road to the diagram, which I have done. And then CII says find the maximum flow traffic. So CII says find the maximum flow traffic from A to E overall, okay, after this road is built. So we already know, all right, let's go through it again. So same thing, you're starting off at 300 from A to B, and from 300, from B to C again, I can only go through 300, and then from C to E, again, I would only end up with 300 over here. So going down that route, okay? And then looking at the other route, I can go 500 this way. Now, what's interesting here is that opening up this road, you see, even if you split it up, even if it was 200 went up this way and then 300 went this way, actually 300 can't go that way. So 150 goes through this section. That means I still have a remainder of that 500 can find another route. Yeah, so 150 goes this direction. Then the remainder, which is 350, isn't it? Yeah, I think it is 350. So 350 will now go down this route, because 150 went this way, and the other 350 can go this way because this has a maximum of 500. True? And then so I end up here at 350, and remember this has a capacity of 800, so 350 can still go through. So essentially I get all of my 500, and I also get all of my 150 from the bottom there. So technically I get a total of 800 cars being able to get through by simply opening up D to C. You see that sort of concept of minimum flow. I now can see that it is possible with 300 plus essentially the 150 plus the 350, because I've opened up that extra road. That now gives me a total of 800 cars as my maximum. Okay, so that's what makes this problem interesting, looking at maximum flows.